Right, in this lesson, we're finding the unknown side of a right triangle using Pythagorean theorem. Yesterday, we spent some time understanding it, and in this lesson, um, trying to figure out that unknown length. And we actually know it's 3. We had this triangle yesterday, but let's look how that works. So the first thing that you're going to do is you have to spot where is that right triangle, and we need that because directly opposite, and I would use highlighters if you have them, it just makes it easier. Opposite is that long piece, and that's important in our Pythagorean theorem. And the other pieces, do you remember what they're called? These pieces here? And that's right, we call them legs. These are the two shorter sides, and this is the longer side. And we always want to take a look at this before we do anything else on our triangle. So what we found out yesterday, understanding Pythagorean theorem, was that we weren't looking at this number 4. We were looking at the area of a square who has the side length of 4. And so we're wanting to know what is the area of this square up here made by that side of the rectangle. And then the other one is what's the area of this one made up by this side length x here, but we don't know it, but that's what we're going to find out. But we're going to find out this area before we're going to find out what that x is. And then of course over here, what is the area of a square made up by that side length? So that's what the Pythagorean theorem was showing us. So the first thing we're going to do is let's go make up that areas. And this one here, this square right here, the area is 4 times 4, which is 16. So that's the area of that square. So I'm going to just throw that on up there. And I don't know this one, but I do know this one. And so here's that square, and it comes from 5 times 5, which is 25. So I know now the area of the square made here and the area of the square made here. This one over here is smaller than this area. So this area has to be smaller than 25. And what I find out, if I'm looking for the smaller one, I'm actually going to subtract those two numbers. And I'm going to take this 25 here, the larger piece, and subtract the 16, and I'm going to get a 9. And understand that 9 then isn't the length over here, but it's the area of that square. And so we'll end up taking the square root of the 9 to get the 3. And that's because 3 times 3 is 9, is the area of that square. And so we come up with our final answer of x equals 3. I can scroll down here and look in your Khan Academy, and you would write the answer is x equals 3. So that's the first one. I'm going to take a look at 2 more and let you do the rest on your own. So let's take a look at this. Can you remember what I'm asking you to do first? What's the first thing we always want to do? Because remember, Pythagorean theorem doesn't work with all triangles. It works with right triangles. And so the first thing you want to do is identify where that square is. Otherwise, we can't even use Pythagorean theorem. And then the very opposite side of that square you want to highlight as your hypotenuse, and then throw in your legs. And your legs are these other pieces here. So that's the first thing we're always going to do with our triangles if we're using Pythagorean theorem. And the next thing I want to do is I want to just toss in the things I know. Okay, the area of this square is going to be 5 times 5, or 25. And I have this 12 down here, so I know that the area of this one is going to be 12 times 12, or 144. And so when I've got these two numbers, you're going to be deciding, am I going to add these two numbers here? There's a yellow one and a yellow one. And over here is the pink one. Which one of these numbers is the largest? Well, that would be this one. So if I'm going to get larger than these numbers, I'm going to have to add those numbers together. And when I add them, Whoa, I'm jumping ahead here. Great. 25 plus 144 equals 169. Where'd this 169 come from right here? It came from adding 25 plus 144, because Pythagorean theorem says that the areas of the legs add up to the area of the hypotenuse, equals 169. And then to get it back to the 13, I'm taking the square root to get the 13. And so let's scroll down and look at our answers here, and boom, answer is C, x equals 13. Now take a look at one more, and again you're going to decide, am I adding numbers or subtracting them? And so let's do this quick. First, where is your square? Yep, it's a right triangle, so this is going to work. And then the opposite side is my hypotenuse. And then where's your legs? Highlight those next. So I've got a leg here, and I've got a leg down here. And then throw in the things that you know. I have a number 8 here, so I know the area of that square is 8 times 8, or 64. That's one of the longer ones. See how I'm putting that in pink? And I know this one. I don't know the x, but I know the 6, and so I can throw in here 6 times 6 is 36. That's one of the shorter lengths. And then the other one up here, I'm gonna put it in here. Something times something's going to equal, you know, and then these two here, see, this is a short one, right? It's the short side. It's these two areas that add up to the 64. And so since I'm looking for a smaller number, I'm going to be subtracting. And look at this. I did this problem actually wrong. I added 64 plus 36, and I'm going to have to fix that. So let's just do it right on the spot. I should have been subtracting, and I would have gotten a mistake. Let's look at this. 64 minus 36 equals 36, 46, 56, 66. Back off 2 would be 28. Would be 28. Why did I have to subtract and not add? Because it's these two that add up to the 64. 64 minus 36 is 64. Okay, so I got that right. So this is a 28. It's like this number in here is 28. And that's the area, so what is the actual side length? And that's when I'm going to throw in a square root. That is not square root 100. Like, forget that. I'm going to have to do the square root of 28. Give me a second to undo this. This is all wrong. I'll undo that. Well, let's look at our answers. Do we have square root of 28? Because that's what our answer should be. Oh, there it is. Square root of 28, and they knew what my mistake was going to be. Look at that. They knew I might add and come up with a 10, but the answer is actually square root of 28. So watch for that on the other ones. Just because you found your answer doesn't mean you're right. So the answer was the square root of 28 is how I find that side length. All right, try the others on your own, and tomorrow we'll take a look at how to determine if a triangle is a right triangle. All right, thank you.